Hi everyone. So our last couple of videos focused on how to get different types of information from the graph of a function. So we talked about finding the domain and range, solving inequalities, and then we talked about increasing and decreasing portions of function and local maxima and minima. And so in this video, I basically just want to review all of that, and we're going to do one kind of more straightforward example, and then we'll do an example that represents a kind of quote unquote real world situation, so that you can kind of see what the significance is of some of these different things we've learned in the context of like a real world situation. Okay, so I want to jump into an example. So we're going to call this function f of x, and we're basically just going to answer a bunch of different questions about this function. So I'd encourage you to pause the video and try to answer some of these yourself, because this is all basically just review from the last two videos. All right, so first question I want to answer is to find the domain and range. Okay, so by looking at the graph, again, when we see the graph kind of heading off the page, that means we can assume it continues in the direction it was already heading. And so we can see that the graph continues to the left and continues to the right. And so therefore, the domain is going to be all real numbers. And then similarly, we can see that the graph continues down and it continues up. So the range is also all real numbers. There's just no point at which the graph ends. And so we know it just kind of keeps going in all directions. Okay, so next question we want to answer is, let's solve the equation f of x is equal to 5. So this is going back actually a little bit earlier in the quarter, but it's related to solving inequalities, so I thought I'd throw it in as well. Okay, so what does it mean to solve f of x is equal to 5? It basically means to find the x values on the graph where the y value is 5. And so we can go to a y value of 5 and just identify, what are the points on the graph with that y value of 5. And we can see that we have x is equal to 2 and x is equal to 8. And so another way of saying that would be that f of 2 is equal to 5 and f of 8 is equal to 5, right? Because when the input is 2 or 8, the output is 5. Okay, so now moving on to an inequality. Now let's solve f of x is less than 9. Okay, so what does it mean again to solve an inequality? Well, it's really similar to solving an equation. It's just that instead of your answer being like specific x values, it's going to be a whole part of the graph. So it's going to be an interval of x values. And so if we're trying to solve f of x is less than 9, that means that we're trying to figure out what parts of the graph lie below a height of 9. So right now I'm kind of indicating here, this would be a height of 9 on the graph. And so we're trying to figure out which portions of the graph lie below that. So we can see already that starting from 9 and going all the way to, starting from x is equal to 0, which is at a height of 9, and going all the way up to x is equal to 6, we can see that at that part of the graph, we're lying below the line y is equal to 9. Now, notice that this is less than. It doesn't say less than or equal to, and so that means we need to make sure that we do not include the values where f of x actually equals 9. So that would mean that I'll kind of put an open circle there to remind us that that we're not going to include x is equal to 0. And then similarly, when we get to 5, well, when x is equal to 6, my bad. When x is equal to 6, y is equal to 9. And so we want to make sure that we don't include that point. And then where else is the graph going to be less than 9? Well, everywhere from from 6 onward. And I apologize, it's probably a little hard for you to read these numbers, so I'm sorry about that if you're having any difficulty. But yeah, so 6, I said 5. I was having trouble reading the numbers, and it's probably even easier for me to read them than you. But anyway, okay, so let's now translate this into an interval or intervals. So the first interval starts at 0, right? That's our first x value, but we're not including 0 because we want things that are just less than 9. And then we go all the way up until 6, but not including 6. And so we have 0 to 6. Then we have everything from 6 onward, but again, not including 6. And so our intervals end up looking like this. So this one's a little tricky, or it's a little different from other ones we did because, you know, we do have this point that kind of breaks things up, right? Because we had this, let me tell you which point I'm talking about. This point here kind of throws things off, right? Like you might look at this graph and say, oh, okay, well, like basically everything down here lies below 9. But because we have this one point that is actually equal to 9, that's why it ends up being 2 intervals instead of 1. Okay, so now we're going to move on to some things that were from the previous video. So I want to answer on which intervals is this function increasing, and on which intervals is this function decreasing. Okay, so remember that we are basically going to go through the graph and figure out, is the graph going up from left to right or going down? And when it's going down, that means it's decreasing. When it's going up, that means it's increasing. And so we can see that the graph is starting by going down, right? This is all going down, decreasing, 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 decreasing. And then when we hit x is equal to 2, the graph stops decreasing. So I'm just putting kind of a parentheses symbol. You could also put an open circle. You can do whatever you want, just something to remind yourself that that point is not actually included as increasing or decreasing. So then again, at 2, it's neither increasing nor decreasing, right? It's flat, but right after 2, it starts increasing, going up, going up, going up, and then it flattens out again at 5. Or sorry, at 6. I keep misreading it. And then at 6, it changes again, and now it's decreasing, 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 and it just keeps decreasing for the rest of the graph. So this tells us that it is increasing on the interval from 2 to 6. So again, remember that you're always going to be giving x values. When the question is on which intervals, is it increasing or decreasing? Your intervals should be intervals of x values. And I think in our next example, you'll get a little bit more insight into why that is. All right, what about decreasing? Well, the first interval starts at negative infinity, right? This graph is going to keep going, and it continues to have this decreasing shape off to the left. And so our first interval of decreasing is negative infinity up until 2, not including 2. And then the next interval where it's decreasing is going to start at x is equal to 6 and then continue to decrease. So 6 onward. Okay, last question is I want to identify the local maxima and minima as well as the x values where they occur. So find all local maxima and minima of this function, as well as the x values where they occur. Okay, so to find local maxima and minima, now we're looking for peaks and valleys in the graph. So anytime your graph has this sort of valley shape, that's called a local minimum. Anytime it has a peak shape, that's called a local maximum. So we can see that we have a valley shape at this point, And so that tells us that we have a local minimum of 5, right? Because that's the y value. And where does that local minimum occur? It occurs at x is equal to 2. So we have a local minimum of 5 at x is equal to 2. And again, we'll see a little more insight about this in the next example, but just remember that when you're talking about a minimum or maximum value of your function, that's always a y value. Whereas when you're talking about where or when that maximum or minimum occurs, that's when you're going to talk about, or that's when you're going to provide an x value. Okay, on the other hand, we have a hill, a peak in our graph at this point. And so that is going to give us our local maximum of 9. And the local maximum of 9 is going to occur when x is equal to 6. So we have a local max of 9 at x is equal to 6. All right, so that's it for this example. So now we're going to look at another example. And basically, we're going to be answering the same types of questions, but for each question that we answer, I want to also kind of interpret it in terms of kind of a real world situation. Not really real world, but we can imagine. So this is a function that is representing the temperature in a certain place, in a certain city, t hours after, let's say, midnight, I guess. Maybe that doesn't make sense. Let's say after, I don't know what time would make sense. This is probably not the most accurate temperature graph if you think about how temperature really works. Maybe let's say after 10 a.m. So this is a function that gives the temperature of a particular city t hours after 10 a.m. And so, by the way, temperature, we want to be measuring that in degrees Celsius, because otherwise this would be a very, very cold city. I mean, it's still pretty cold, but at least Celsius makes it a little less cold. Okay, so what I want to do is for each of the questions that I'm going to ask, I want to first just kind of answer it like mathematically, but then I want to interpret, be able to explain in a full sentence what it tells us about this real world situation. Okay, so first question we want to answer is we're going to find the domain and range. And then again, after we find the domain and range, we're going to kind of explain like what do those tell us about this situation. Okay, so what is the domain of this function? Well, it starts at 0, including 0, and it ends at 8. And notice that I didn't put like these sort of filled in points here, but I could have. If the graph just ends and it doesn't have a point on the end, you can assume those points are included. All right, what about the range? Well, if we look from the bottom to the top and see, what are the different y values that are included, the smallest y value that's included is 0, and the biggest y value that's included is 9. And the graph does touch a height of 9, so we are going to include that. Okay, so now let's think about what this tells us in terms of, this kind of word problem. So the first thing we need to be aware of is what do each of these axes represent? So the function is supposed to tell us the temperature of a city t hours after 10 a.m. So that's telling us that the input variable t is time, right? F of t is the output, t is our input. And so that means that we can label our horizontal axis with hours. And then what does the output represent? Well, the output represents degrees Celsius. So in other words, when we're talking about the domain, we're referring to t values, right? And so that's talking about time. It's a little confusing because time and temperature both start with a t. And then when we're talking about the range, when we're talking about output values, then we're talking about temperature. We're talking about degrees. So what does this tell us? So the domain tells us that, well, it tells us that this is the time period during which the temperatures were being recorded, right? Time goes on before and after this, but this is the data we have. So the domain starting at 0 and ending at 8 tells us that temperatures were being recorded from 0 to 8 hours after 10 a.m., right? Because 10 a.m. was what I said was our starting time. And so what time would that give us? Well, that would mean that the starting point would be 10 a.m. and the finishing point would be 8 hours after 10 a.m. And so that's 6 p.m. So in this case, the domain is telling us basically the times that are being kind of considered here. And then what is the range telling us? Well, again, the range or the outputs, the y values on this graph are telling us temperature because that's the output of the function. And so if the range is from 0 to 9, that means that the city experienced all of the temperatures between 0 and 9 degrees Celsius, right? Because the graph covers every single y value between 0 and 9. And so that means that the city went through or experienced every temperature from 0 degrees Celsius to 9 degrees Celsius during the time period that it was being tracked. Okay, so next question I want to ask is I want to solve the equation, or actually first let's do one other thing. Let's evaluate f of 2. This again is kind of review, but I think it's a good reminder. So I want to evaluate f of 2 and then also explain what it means in this context. Okay, so to evaluate f of 2, remember that just means that we're looking at an input of 2 and we're looking for what is the output. And so we see that when t is equal to 2, f of t is equal to 4. And so that tells us that f of 2 is equal to 4. So what does this tell us in terms of this situation? Well, remember that t, our input, represents the number of hours after 10 a.m. So this means that 2 hours after 10 a.m., so that would be at 12 p.m., right, at noon, the temperature is 4 degrees Celsius, right? Because the input is the time and the output is the temperature. Okay, so what would it now mean to solve the equation f of t is equal to, let's say, 5? And by the way, on some of these, we might need to estimate a little bit. And that's why I included this grid with a little bit more detail so that would kind of aid us in our estimation. Okay, so what does it mean to solve f of t is equal to 5? Now that means that we're looking at a height of 5 and we're trying to figure out what are the t values that correspond to that height of 5. So I'm just going to go through the graph and draw a point on all the places where it looks like the graph has a height of 5. So we have 3 different points. So the first point, it looks like, happens at t is equal to 1. So that's going to be our first answer. So what is the second point? Well, this one we're going to have to estimate a little bit. So to me, it looks like, so notice that we have 4 divisions. So it would be like 4.25, 4.5, 4.75, and 5. So to me, I would say it's like somewhere between 4.25 and 4.5. So maybe let's call it 4.4, just to kind of estimate. And then the third one, it looks like happens at about, so somewhere a little bit just after 7.25. So maybe let's call that one, I don't know, 7.3. Okay, so what is this telling us in terms of this temperature situation? Well, in the previous one, we were given the time, right? And our answer was the temperature. And so this one's the opposite. So this time we were given the temperature, so our answers refer to the time, right? So that tells us that there were 3 different times where the temperature reached 5 degrees Celsius. So the temperature was 5 degrees Celsius at 3 different times. T is equal to 1, or actually let me just write it like this. I'll say at 1 hour, approximately 4.4 hours, and approximately 7.3 hours after 10 a.m. And we could go through and try to estimate what that would give us in terms of times, but I don't think that's really worth the effort right now to take these decimals and translate it into minutes and all that. But yeah, we're just talking about the amount of time after 10 a.m. So by the way, obviously this is not like the most realistic temperature graph. It's probably rare that it would kind of do all this cycling, but you never know. There might be some weird place where the temperature goes up and down a lot. Okay, so next we want to solve an inequality. So we're going to solve f of t is greater than or equal to 4, and then kind of explain the meaning of that inequality. Okay, so f of t is greater than or equal to 4. That means that we're looking for the portions of the graph that lie above or at a height of 4. Okay, so I'm going to draw in like a line at a height of 4 to kind of remind us where that is. And so we just want to record what are the portions of the graph that lie at or above that height. And so we can see that we already have a point at t is equal to 0, that is at 4. And then it's above, it's above, it's above, it's above, and it's still at a height of 4 at 2. And at that point it ends, it stops being above 4. And so where does it start being 4 again? Well, at t is equal to 4 actually, right? At t is equal to 4, we also have an output of 4. And then the graph continues to be above 4, right? This whole portion of the graph, this is all above 4, all above 4, all above 4. And where does it stop being above 4 at this point here? So what are these intervals? Well, the first one is the interval from 0 to 2. And we're going to include the endpoints because it was an inequality with an equal sign, right? We're looking for greater than or equal to. So our first interval of t values is the interval from 0 to 2. And then we have a second interval. The second interval is going to be from 4 to approximately 7.5. I can't tell if it's exact, but it's close enough. So let's just say 4 to 7.5. Okay, so what does this tell us about our function or about our, the temperature of this city? So remember that the intervals we answered, those were t values, right? So those tell us times. So just thinking about what these intervals mean, the first one means all of the time from 10 a.m. to 12 p.m., right? All of the time from t equals 0 to t equals 4. And then the second one means all the time from t equals 4 to t is equal to 7.5. So what is happening during these time periods? Well, these are the time periods when the temperature is at or above 4 degrees Celsius, right? So the temperature is greater than or equal to 4 degrees Celsius during 2 different time periods. The first time period is going to be from 0 to 2 hours after 10 a.m. And so let's translate that because this one isn't so hard to translate. So that is going to be from 10 a.m. to 12 p.m. And then it's also going to be greater than or equal to 4 on another time period. And so that's going to be from 4 to 7.5 hours after 10 a.m. And so that would give us 2 p.m. to, so 7.5 hours, that would be what, 5:30, I believe. oops. So that's kind of one way of understanding, why are our answers intervals of t-values? Well, because we're answering the times at which something happened. Okay, so next up, I want to find the intervals of increasing and decreasing. Okay, so you can go back to our picture and, same idea from what we did in an earlier problem. We're just going to look for where's the graph going up, where is it going down. So it looks like it starts increasing from the get-go, right? From 4 up until 1, at which point it stops increasing. Then it starts decreasing, stops decreasing at 3, starts increasing again. It's increasing all the way up until, what is this? T is equal to 6. And then it's decreasing from there to our stopping point. Now, one thing that hasn't really come up yet, and it's not really important, is what goes on these two endpoints, like at 4 and at 8. I would say that you could go either way as to whether you include them in your interval or not, because we don't have any data about what was happening beforehand, right? This was like the starting point. So I think it makes a little bit more sense to exclude those points. So we're going to exclude the beginning and end of these intervals. But really, either way, I think it just kind of depends, honestly, on what class you're in, whether they're going to be included or not, or like which textbook you're using or something like that. Okay, so the first interval where it's increasing was from 0 to 1. So we can see that it's increasing from 0 to 1, and then also from 3 until 6. Okay, so what does that tell us in terms of this situation? Well, it tells us that the temperature was increasing, right? Because we can see on the graph, like the temperature was going up. So when was it increasing? It was increasing during the time periods from 0 to 1 hours after 10 a.m. So that would be from basically 10 a.m. to 11 a.m., not including at 10 a.m. and at 11 a.m., and from 3 to 6 hours after 10 a.m. And so that would be from 1 p.m. to 4 p.m. So hopefully now you can kind of see why it's not like an arbitrary choice that we record the X values, or in this case, the T values, when we're talking about increasing or decreasing. It's because when you have a real world situation, generally the X axis or the T axis is what's going to represent time. And really, if you're keeping track of whether something's increasing or decreasing, you're probably trying to keep track of time periods. In this case, we're talking about hours, but it could also be years or whatever the time interval is, where something is either going up or down. Okay, similarly, the function is decreasing from 1 to 3, and then also from 6 to 7. So it's decreasing from 1 to 3, and then also from 6 to 7. And so what does that tell us? That tells us that the temperature was decreasing from, I don't know why I wrote above the time periods, I don't really have to write that, but from 1 to 3 hours after 10 a.m. So what would that be? That would be from 11 a.m. to 1 p.m. And then again from 6 to 7 hours. Or sorry, did I say 7? I think it should have been 8. I'm sorry, my bad. The graph goes until 8. I'm not sure why I wrote down 7. 8 hours after 10 a.m. And so that would be from 4 to 6 p.m. Okay, almost done. The last thing I want to do is I want to identify the local maxima and minima as well as the t-values where they occur. And then again, we'll try to interpret what that would tell us in this situation. Okay. So going back to our graph, we look for our peaks and valleys, and we can see that we have our first peak at t is equal to 1. We have this peak at a height of 5. So maybe let's just do the two local maxima first and translate those, and then we'll do the local min. So the other local max we can see is we have a peak that occurs at about t is equal to 6, and it looks like it's at a height of 9. And so this tells us that we have a local max. And I'm going to have to scroll back up because I don't remember what it was. So the first one was a height of 5 at t is equal to 1. And then we also had a local max of 9, and that was at t is equal to 6. So what does that tell us in terms of the problem? Well, it tells us that, thinking about like, what is it, like this shape of having kind of a peak or a valley, that's telling us about these sort of spikes or dips in the temperature, right? If the temperature goes up and then goes back down, that means it's spiking. And so what we can say is that the temperature has a spike at 1 hour after 10 a.m., so that would be at 11 a.m. And it reaches a height, or reaches a temperature of 5 degrees Celsius. And so what I just want to point out here is that notice I say at 1 hour. I don't say it has a spike of 1 hour, right? Because the part that's actually the maximum is this, it's the temperature. The time is just like what's telling you like when that happens. And so similarly, we can say that the temperature has a spike at 6 hours after 10 a.m. And so that would be at 4 p.m. And at that time, it reaches 9 degrees Celsius. And one other thing I want to point out, there's one kind of difference between these two local maxima, and it's that the second one is actually also the absolute max, right? And so what does that mean? Well, it means that 9 degrees is the absolute maximum temperature that this city ever reaches during this time period. And so again, that's why you would say the absolute maximum is 9. The absolute maximum temperature is 9 degrees. When does that maximum occur? It happens at t is equal to 6 hours. And then this other one, it isn't the absolute highest, but we can see that it's still higher than the heights around it. And so therefore it's this kind of spike idea. Okay, last thing we have is this dip in the graph. So we have a local min. And this one, it just so happens that the x and y coordinate are the same, right? And so the local min is 3, and it happens at t is equal to 3. So we have a local min of 3 at t is equal to 3. And so that tells us that the temperature dips at 3 hours after 10 a.m. So that would give us 1 p.m. And what temperature does it reach when it does that dip? It reaches a temperature of 3 degrees Celsius. However, that's not the lowest temperature overall, right? If we look back at our picture, we can see that the temperature actually does go lower than that later on. But it's this kind of dip that we're looking for, right? A place where it goes lower, but then it also goes back up. That's really what a local max or min is. It's not so much that it's the lowest point in the graph, it's just that it has this certain shape to it where it's dipping or spiking. All right, so that is it for this video. And then in our next video, we're going to be talking about average rate of change, which is a new section in the book, but it's still kind of along these same lines of basically information that you can get from the graph of a function. So I'll see you all in the next video.